Welcome, dear learners, to our session. My name is Professor Janko. Please, you are advised to like and subscribe to this YouTube channel. And if you are interested in a one-on-one online tutorial session, feel free to email me at the email address ftchris@yahoo.ca, as you can see on your screen. So once more, welcome to our presentation. Throughout this presentation, I will guide you through deriving a simple compound angle identity. We're going to explore the importance of learning this study unit, and we will dive into visual derivation. So prepare to expand your trigonometric toolkits. Why is this unit very important? In fact, simplification is much more easy when you know this compound angle formula, because it helps us simplify complex trigonometric expression. And also note that the expanded form of these compound angles make calculation much more manageable. What are the learning outcomes? And by the end of the session, you should be able to master these formulas. This implies you have to learn and understand the core compound angle identities. You should also be able to learn the steps to derive compound angles formula using a specific diagram. So our goal is to help you derive the formula, which states that cosine of alpha minus beta is equal to cosine of alpha times cosine of beta plus sine of alpha times sine of beta. In an attempt to achieve this goal, you're advised to recall the formula, which states that the distance between 2 points A and B is equal to the square root of xa minus xb all squared plus ya minus yb all squared, whereby the point A has coordinate xa, ya, and the point B has coordinate xb, yb. You equally have the cosine rule, which you have to recall, which states that if you're given a triangle, the side A squared is equal to the side B squared plus the side C squared minus 2 times the side B times the side C times the cosine of the angle A. Hopefully you do remember these geometric rules. Now, what are the steps? The first step towards deriving the cosine of alpha minus beta is to construct a diagram, or precisely construct angles alpha and beta on a unit circle. Next, you have to project these angles on the xy axis. And after, you have to apply geometry to find the cosine of the combined angles. We will use this diagram on your extreme right to achieve our goal. So on this diagram, we have a triangle POQ. We have our angle beta here, our angle alpha here, and the angle alpha minus beta. So the first step will consist of rewriting the coordinates of the points P and Q in terms of alpha and beta. So the first step will consist of, in fact, we have to rewrite the coordinates of P and Q in terms of alpha and beta. How do we achieve this? Let's go back to our circle. On this circle, we can introduce a new point, let's say R here, in order to obtain the triangle QOR with angle beta here. You see, this is a right angle triangle, right? So we can apply the sine ratio here to obtain sine of our angle beta equals to opposite over hypotenuse, and our opposite here, this length, because we have Q as x1, y1, so this length here is y1, and the length from O to R is x1. So our opposite is y1, and our hypotenuse, because we are dealing with the unit circle, our hypotenuse is 1. Therefore, y1 is equals to sine of beta. In a likewise manner, we obtain cosine of beta to be equal to adjacent over hypotenuse. Our adjacent is x1 over 1. This implies x1 can be written as cosine of beta. So this implies our coordinate, which is initially our point with coordinates x1, y, can now be written as cosine of beta, sine of beta. Okay. Now, remember, if this is alpha, this is beta, this is alpha, therefore this will be equals to 180 degrees minus alpha. Okay, so If you introduce another point, let's say s, because you're on the negative side of the x-axis, this can be minus x2, and here we're going to have y2 because of this assumption in the beginning that P has coordinate x2, y2. So therefore, in that, this is going to give us a right angle triangle. In triangle, let's have it as POS. This is our triangle. We're going to have that sine of 180 degrees minus alpha is equals to what? Opposite over hypotenuse. Still here, the hypotenuse is 1 because we're dealing with a unit circle. So our opposite will be y2 over 1. Remember, from grade 11, this is an identity, so therefore this is equals to sine of alpha equals to y2. Now, we can apply the same concept to cosine of 180 degrees minus alpha is equals to minus x2 adjacent over hypotenuse. This is equals to our trigonometric identity from grade 11 minus x2. This minus cancel, this minus cancels. We're going to have x2 to be equals to cosine of alpha. So we can conclude that our point P, which originally had coordinate x2, y2, can be written as P with coordinate what? Cosine of alpha minus, cosine of alpha and sine of alpha. Okay, so we are going to use this coordinate in terms of alpha and this coordinate in terms of beta to achieve our derivation of the formula. Now we've rewritten this. The next step will now be to use the distance formula. We have to use the distance formula. The next step, use the distance formula. To express the length PQ squared. Okay, so we have, according to distance formula, our length PQ all squared is equals to, remember, x2 minus x1 all squared plus y2 minus y1 all squared. We now replace it with our new values that we obtained from our previous slide. So we are going to have now cosine of alpha minus cosine of beta all squared plus sine of alpha minus sine of beta all squared. We now expand to obtain cosine squared of alpha minus 2 cosine of alpha times cosine of beta plus cosine squared of beta. On the other side, expands to sine of alpha squared, okay, minus 2 sine of alpha sine of beta plus sine squared of beta. Remember the trigonometric identity, we have to go with according to our trigonometric identities that we know from our previous knowledge, okay? So we have this. We can now write this as cosine of squared of alpha times plus sine squared of alpha. We group it like this for simplification. Cosine squared of beta plus sine squared of beta, okay, minus 2 cosine. We can factorize our minus 2 from this expression and this expression. So we're going to have cosine of alpha, cosine of beta, plus sine of alpha, sine of beta, after factorizing minus 2 from this expression and this expression. So this is equals to 1 plus 1 minus 2 times bracket cosine, okay, cosine of alpha times cosine of beta plus sine of alpha times sine of beta. So we can simplify this further to obtain 2 minus 2 times bracket cosine of alpha times cosine of beta plus sine of alpha times sine of beta. Let's say this is equals to equation 1. The next step will now consist of writing our length PQ using the cosine rule. So let's consider the triangle POQ. We now apply the cosine rule to obtain the length PQ all squared. That will be equals to, remember the cosine rule applied to this triangle will now be PO, the length PO squared plus the length QO squared minus 2 times the length PO times the length QO times cosine of alpha minus beta. Okay, so remember, since you're dealing with a unit circle, this then is equals to 1. We have minus 2 times 1 times 1 times the cosine of alpha minus beta. So this gives us 2 minus 2 times cosine of alpha minus beta. Let's say this is equal to equation 2. So we equate equation 1 and equation 2 because these are the same values, PQ squared and PQ squared in the two equations. So what happens now? We are going to obtain 2 minus 2 cosine of alpha minus beta equals to 2 minus 2 times bracket cosine of alpha times cosine of beta plus sine of alpha times sine of beta. So if we centered on this side of the equation, we're going to have 2 minus 2 cosine of alpha minus beta. Okay, that equals to minus 2 times bracket cosine of alpha times cosine of beta plus sine of alpha times sine of beta. We cancel this, we'll be divide now all through. We divide all through by minus 2. We're now going to obtain cosine of alpha minus beta. That equals to cosine of alpha times cosine of beta plus sine of alpha times sine of beta. End of proof. Our conclusion now is that the cosine of alpha minus beta is equal to cosine of alpha times cosine of beta plus sine of alpha times sine of beta. So here are a few takeaways. Remember to commit this compound angle formula to your memory, and remember to practice deriving this formula using the unit circle. Once more, remember to like and subscribe to this YouTube channel. Thank you for following this video. See you in the next video. Thank you. Bye.